Welcome to today's Bellringer. We're going to multiply 35 and 6/10 times 10 and 100. And in order to do that, we're going to take 35 and 6/10 and just move our decimal point over one spot to the right, because with multiplication our numbers get bigger. And so our product or answer is going to be 356. Now to multiply that by 100, we need to rewrite 35 and 6/10 and then add a decimal point, or maybe even, or sorry, not a decimal point, add a 0 or maybe even 2 zeros as a placeholder. And then just move your decimal point over 1, 2 spots. So our product is going to be 3,560. Now we're going to divide 35 and 6/10 by 10. So that's like taking our, let's imagine that it's $35.60, and we're going to divide it among 10 of our best friends and see how much money everybody gets. We're going to move our decimal point over one spot to the left this time to make our number smaller. So that means that if we are imagining that this is money, we're saying everybody's going to get $3.56 when we share it amongst our 10 friends. So 3 and 56 hundredths is how you would write that without the dollar sign. Now we're going to do 35 and 6/10 divided by 100. So we're going to rewrite 35 and 6/10. Now when you're dividing by 100, I would say put your 0 as a placeholder on the other side of your number. Put it on the left side, just as a placeholder to keep yourself organized as you're moving that decimal point. So now I'm going to move my decimal point one spot, 2 spots over, and so now my number is, or my quotient, 356 thousandths. Make sure that when you're answering these, make it easy for me to tell the difference between your comma and your decimal point. That makes it easier for me to grade your work. All right, now it's time for our daily measurement problem. We are converting centimeters to meters. So is that fly to horse or horse to fly? Centimeters to meters. Centimeters are smaller than a meter. So that would be fly to horse, divide, of course. We're going to divide 125 centimeters divided by 100 centimeters in each meter. And I can remember that there's 100 centimeters in 1 meter because centi means 100. That's just a little reminder for you, right? Like 100 cents in a dollar. Now, in order to divide this, I need to put my decimal point in. Now, of course, there's always a decimal point understood to be at the end of every whole number. We just don't usually include it if there's no decimal to go with it. And then move your decimal point over 2 spots to go with your 2 zeros in 100. 1, 2. So now my quotient, or my answer, is 1 and 25 hundredths of a meter. Now I'm going to convert 5 kilometers to some number of meters. So now I'm going to multiply because a kilometer is bigger than a meter. There's 1,000 meters in 1 kilometer. And kilo means 1,000. So that's my memory trick for remembering that. 5 kilometers times 1,000 meters in each kilometer will give me 5,000 meters. Now I remember this because of like the 100-meter dash, and usually meters just makes me think of like swimming races. Okay, now we're going to find an equivalent fraction for 3/10. And we've been kind of practicing this for the last week or so. I'm going to divide my 1 whole into 10 equal pieces. And then I'm going to shade in 3 of those pieces. When I'm finding an equivalent fraction, it's important to remember that my numerator and my denominator will change, but the size of my whole will not change. My 1 whole can't change sizes. So I'm going to take my 3/10 and I'm going to cut each of these tenths in half. So now I have 2 pieces where before I only had 1. So I'm effectively multiplying both my numerator and my denominator times 2. And that gives me a total of 6 out of 20. So 6 out of 20 is equivalent to 3 out of 10. Okay, so now I'm going to add 12 4/5 plus 11 1/10. And I'm going to show you this using an area model only because I noticed that on the tests that you guys have coming up soon, they have a lot of area models for fractions and they want you to be able to work with them. So I'm going to start by taking 12 wholes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that was easy. Got 12 wholes, and then I need to add 11 more to that. Let me just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, good. Now I'm going to add 11 more to that. Okay, so that's what this will look like. And of course, 12 plus 11, that's the easy part to do. 12 plus 11 will give us 23, and I can count those up in my area models here. Now the fraction part, that one's a little bit trickier, so let's look at how we would do that. I'm going to take one of my wholes, and I'm going to duplicate it. Okay, now on one of these wholes, I'm going to represent 4/5. So I'm going to shade in 1, 2, 3, 4, and then that 1/5 has to stay blank. Okay. And then on the other one, I'm going to show 1/10. Here I have my 1/10. Now, the reason your teachers always tell you that you need a common denominator is because there's no way to combine this 4/5 with this 1/10 without taking your fifths and cutting each one of them in half, which is like multiplying them by 2. So now, instead of 4 out of 5, I have 8 out of 10, and it's much easier to add my 1 out of 10 because I can just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. So my total is 23 9/10. Okay, so now here we are. We're getting ready to do our line plot, and I have to confess I didn't do this in the Bellringer video for yesterday because by the time I was making that video, it was like 9 o'clock at night. It was just taking me too long. So I'm going to go over this one today, and then I give you permission to skip the line plot from yesterday, from Monday's Bellringer. You have my blessing. All right, so we're going to do this, and it's just easier for me to rewrite these fractions here because the way they have them, I'm just not used to always looking at fractions like that. So sometimes it's easier for me to rewrite it the more traditional way, which is numerator, fraction bar, denominator on the bottom. So that's why I did that. Now I have to find my lowest value and my highest value. And my lowest value, I can tell, is 1 1/4. And my highest value is 2. So I'm going to do between 1 and 2, and then cut the space in between 1 and 2 into fourths. So I have 1 and 1/4, 1 and 2/4, 1 and 3/4. And then I just have to put an X on top of each value. For some reason, when you guys are passing in your work, I'm still seeing people pass in work with fractions labeled but no X's. The X is what actually represents your data. So let's say that this data represented like the number of hours kids worked on their math homework last night. So this kid here worked on his math homework for 1 hour and 1/4 of an hour. So 1 1/4 of an hour. And this kid worked on his math homework for 1.5 hours. And this kid worked on his math homework for 1 3/4 of an hour. If I added another X, that would be like saying, oh, I have 2 kids who did their math homework for 1 3/4 of an hour. So the X is really critical. That is what tells the person looking at your line plot how many pieces of data you have for that number on your line plot. Don't leave your X's out.